planes and all that cool stuff, highlighters really, really, really help. I guess, and your homework will be on paper, so that way you can highlight, because that would be very difficult to do on the computer screen. So now we get into the big meat and potatoes of what geometry is all about, recognizing types of angles. Okay, so here's the new picture, right? But it should seem pretty familiar if I was to cover up this stuff down here. This is our old picture that we've been doing for a couple chapters now. And we should know some types of angles in this picture already. We should know about vertical angles in linear pairs. Aren't angles 1 and 3, which are right across from each other, vertical angles? And hopefully remember that vertical angles are congruent, and angles 2 and 4 are also vertical angles. And then angles like 1 and 2 that touch each other and form a line, those are a linear pair. Well, we got a whole nother set of angles down here, right? I kind of call this like two houses here. We got upstairs and downstairs. And let's just kind of start by defining our words here. A transversal is a line that cuts through two other coplanar lines. So please define these words. If you need to pause the video to actually write them down, please do that, but I'd like to just kind of keep moving. A line that cuts through two other coplanar lines. So check me out here. I got a blue line, I got a red line, and I got a green line. And the transversal is the blue one, line T. It cuts through those two other lines, and it formed 8 different angles when it did that. Well, there's many types of angles in this picture. We already know about vertical angles in linear pair. Here's what corresponding angles are. Corresponding angles are angles in the same position with respect to the transversal. Like I said, jot that down. Angles in the same position with respect to the transversal. So, let me show you my method. Remember, the blue line here is the transversal. If we just kind of pick on one of these houses, if we pick on upstairs, let's pick on angle 1 right here. Let's find angle 1's location in relation to the transversal. Isn't angle 1 to the left of the transversal? Right? It's on the left side. It is also above the green line that belongs in its house, right? So angle 1 is to the left and above. We just want to go downstairs here and figure out which angle is also to the left of the transversal but above its line, and that would be angle 5. Angle 5 and angle 1 are what we call corresponding angles. They are in the same position with respect to the transversal. Also, if you look at like angle 4 right here, is an angle 4 to the left and below its line? It corresponds with angle 8. They are corresponding angles. And then angle 2 is to the right and above. It corresponds with angle 6. And finally, angle 3 and angle 7 are also corresponding angles. Right? They're in the same position with respect to the transversal. And if we would just stop there and never learn any other types of angles, it really wouldn't be that complicated. It's like, oh yeah, those are corresponding angles. But we have a whole other types of angles. Another type is called alternate interior angles. Angles that are on alternate sides of the transversal, but between the two lines. So please take a moment to jot that definition down. And now here, note, the transversal is blue, and I just highlighted the other lines red. I could care less about telling them apart. But I want angles on alternate sides of the transversal. That means if I pick one angle on the left, the other one's going to be on the right, right, on alternate sides of the transversal, but between the two other lines. That's why they're called interior. And as you can see, if I shade this, all this green stuff, that's not between the two red lines right there. That's the exterior, right? We don't care about that. We care about the interior, all of this stuff between the two lines. So let's find a pair of alternate interior angles. Let's pick an angle to start with, angle 3. Right? You got to pick one to start with. Now, you know that 1, 2, 7, and 8 are out because they're on the exterior. We only have choices between 4, 5, and 6. Out of these three choices, 4, 5, and 6, we can eliminate 6 from it being its alternate interior angle for the simple fact that 6 is not on the alternate side of the transversal. Since 3 is on the right, its alternate interior angle has to be on the left. Right? So 6 was not a choice. So we're down to 4 or 5. And the question is, which one of those is it? Well, it can't be 4. reason why it can't be 4 is because angles 3 and angle 4 are what we call a linear pair, right? They're already a type of angles we knew about. So you can't be like a linear pair and alternate interior angles at the same time. You just can't be two different things. So angle 3 and angle 5 are alternate interior angles. They are on alternate sides of the transversal, and they are between the two lines. And you can also see that if I go back, that angle 4 and angle 6 is also a pair of alternate interior angles. They are between the two lines and on alternate sides of the transversal. And they're not a linear pair, excuse me. So alternate interior angles. And then finally, the consecutive interior angles are angles on the same side of the transversal between the two other lines. On the same side between the two other lines. So again, if we pick an angle, they have to be interior, right? So we only got between 3, 4, 5, and 6, those angles right there. If I pick on angle 3, since they have to be between the two lines right here, and on the same side, you only got one choice. It's got to be angle 6, right? So angle 3 and angle 6 are consecutive interior angles. You might accidentally hear me call them same side interior angles because that's what our book last year called them, was same side interior, but consecutive interior angles. They're on the same side of the transversal in between. So 4 and 5 are also consecutive interior angles. So yay! Now, here's all the choices. It says classify these type of angles as either alternate interior angles, corresponding angles, vertical angles, linear pair, or consecutive interior angles. So here's the picture they want us to use. Let's name these angles. Angle 1 and angle 3. Right, so I'm going to circle them and then erase them since I'm using a pencil and you're using a pencil. Just finding the angles in the picture. What kind of angles are those? Those are vertical angles because they're right across from each other. So we definitely knew about vertical angles. Now, in part B, angle 4 and angle 8. Those are one of them new type. Since angle 4 is to the left of the transversal and below its line, and angle 8 is to the left and below, those are what we call corresponding angles. And we'll spell the whole thing out. Corresponding angles. You can use the angle symbol. That's fine. Then angles 4 and angles 5. So let me get my eraser. Angle 4 and angle 5. They are between these two lines, so they are interior, and they're on the same side, so those are consecutive interior angles. And what I'd like you to do is to finish this set of problems. Do D, E, F, G, and H. Why don't you pause the video and give those a finish, and then we'll see if you got them right. So give her a pause. So hopefully on D you had alternate interior angles for 4 and 6, and 7 and 8. They are a linear pair right there. They're right next to each other, forming a line. And 7 and 3 are corresponding angles. And 4 and 6 were alternate interior angles. And 3 and 6 were consecutive interior angles. Now I know this is kind of weird over a video, because if you had a question, please come see me if you had a question, because it's totally okay. There was lots of questions in class. It's like, why is it this? Why isn't it this? Why isn't it that? So if you're not sure about this, you gotta come see me because of the fact that this is a huge part of what we're going to do for the rest of the year, right? What kind of angles are these? What kind of angles? So, awesome. Now, here's a big boy. Here's a theorem right here that says if two lines are parallel, then corresponding angles will be congruent. So this is the actual theorem. If two lines are parallel, then corresponding angles will be congruent. Notice it was an if-then statement. This is the hypothesis of that if-then statement, that conditional, right? And this guy over here is the conclusion. Well, remember, the hypothesis is like given information. Like, here you go, man. I'm giving you something. They're basically telling me that we have parallel lines. And if we have parallel lines provided for us in the picture, then that means that any pair of corresponding angles will be congruent to each other. So when we start doing our proofs, this is what we would be expected to write down, this whole sentence in that justification step. Holy cow. Mathematicians don't like to write sentences, so we're going to abbreviate this. And we start with the hypothesis. The hypothesis, all boiled down, is about parallel lines. So the way we abbreviate that is this means parallel, and of course the word lines means line. So parallel lines. Then leave yourself a little space here. We're going to put something in this space, but we're going to write what the conclusion would be justified. It says corresponding angles will be congruent, so we'll abbreviate corresponding, C-O-R-R, and angles, we'll do the angle symbol with an apostrophe S, and they're supposed to be congruent to each other, so remember that's the congruent symbol. It's the equal sign with the little squiggly above it. But since this was a conditional, this if-then stuff, what we need to do is put this cool arrow right here, which means an if-then statement. Now, earlier in our book, they used a single arrow, and I like to use the double arrow just to stay consistent with what I've done in the past. So that double arrow right there, and here, put yourself a little note of how that's read out loud. You say that as implies. So this is the justification that we're going to write down. And let me tell you, it's a pain in the butt if you don't know what it says. So this says parallel lines implies corresponding angles congruent. One more time. Parallel lines implies corresponding angles congruent. Now, every time you write that down, you should say it to yourself, because otherwise, if you don't say what it means, here's what kids think. They're like, oh, slash, slash, lines, funny arrow, core, symbol, squiggly thing. I mean, obviously that makes no sense if you don't know what any of this stuff means. So, parallel lines implies corresponding angles congruent. And implies is a very fancy way to just say means. Parallel lines means that all your corresponding angles will be congruent. So let's try some problems down here. What are they giving me, baby? They're giving me that A is parallel to B. Again, we're reading stuff, reading it for what it means. A is parallel to B. Whoa, I got a picture. We should go to that picture and mark what that means. I got to mark these lines parallel. Remember, we do that with arrows. So I have marked what they gave me. They also said measure of angle 1 is 70 degrees. I will put that in the picture. And don't forget the little degree symbol. Just don't put a 70. Okay? Now, they want us to figure out all these other angles and justify each reason. I typed this out. This is my train of thought going here. They gave me angle 1. Look which angle I went to directly after that. I went straight to angle 3. Why in the world would I go to angle 3? Oh, because those are vertical angles. And I know that their measures have to be the same. So, 70 degrees. And the reason I knew that was because of the vertical angle theorem. And we can abbreviate just like we've done in the past chapters. That's how I knew that. Then my train of thought says, I'm going to figure out angle 2 next. If I want to figure out angle 2, I need an angle to help me. I could use angle 1 if I want to, or I could use angle 3 if I want to. It's really no big deal, but regardless of which way I do it, I should get 110 degrees because angle 1 and angle 2 are what we call a linear pair, and angle 2 and angle 3 are a linear pair, so I know that this puppy has to be 110 degrees by the linear pair theorem. Linear pair theorem says if two angles are a linear pair, then they're supplementary. It means they add to 180. So since this is 70 degrees, this has got to be 110 degrees. Then, of course, my train of thought immediately goes to angle 4 right after that because I'm using this 110 to say, oh, angle 4 is a vertical angle with that. It's also got to be 110 degrees because of the vertical angle theorem. And to be quite honest with you, you could have used 3 to help you. You could have used 1 to help you. The snowball's kind of rolling down the hill now. It's like, oh, man, I'm really getting the ball rolling. I can justify this stuff however I want. But now we get stuck because that took care of everything upstairs. That was all review from the past. I got to get downstairs somehow and figure out all these other angles. And of course, my train of thought went to angle 5 because the angle that they really gave me something to start with was angle 1. Right? I had angle 1. I can use that to figure out angle 5 if I just know what kind of angles those are. Oh, those are corresponding angles. They are in the same position with respect to this transversal right here. So, you got to realize, though, that corresponding angles will not always be the same. You have to have something given to you first. You have to have parallel lines given to you. Oh, cool, we do have parallel lines. So, since the measure of angle 1 is 70 degrees, measure of angle measure of angle 5 should also be 70 degrees, because if you have parallel lines, those corresponding angles will be congruent to each other. And that's exactly what we're going to write right here. If we have parallel lines, which which we do, that means that my corresponding angles will be congruent to each other. Parallel lines implies corresponding angles congruent. So if they give you parallel lines, all your corresponding angles should be congruent to each other. So measure of angle 6 is where I go next. Now it's like free for all. It's just crazy. You could justify however you want. To figure out the measure of angle 6, you could use angle 5 to help you, or you could actually use angle 2 to help you, because aren't 2 and 6 corresponding angles also? I'm going to go with 5. Right, I'm going to use 5 to help me because that's the linear pair theorem, and I think that's easier to write down than this justification, linear pair theorem. Then angle 7 right here, you could use many things to help you. You could use 6 to help you. You could use 5 to help you. You could use 3 to help you. But one way or another, I think this information right here, these angles across from each other, those vertical angles, is the easiest way to justify. And then measure of angle 8, definitely 110 degrees, and you get your choice. I'm going to use angle 6 to help me with the vertical angle theorem again. The numbers should all be perfect, right? The real trick to the whole deal was how in the world did I get from upstairs to downstairs? I had to use this justification, which says parallel lines implies corresponding angles congruent. So last problem here, sorry. Last problem here. Use the picture at the right to write an equation to solve for x. And we actually will solve for x. Then justify our reason. So, whoa, use the picture. Well, let's see what we got here. I got some expressions in these angles right here, but we did a good job in class of recognizing this. What do they really give us? They give me parallel lines. It's like a hidden secret. They're telling me line M is parallel to line N just by those arrows in the picture right there. You know, they're not going to do that often. They're not going to say, hey, check it out, line M is parallel to line N. They actually have it in the picture, so you have to realize you were given parallel lines. Hey, what kind of angles are these right here? Aren't they corresponding angles? So, since I have parallel lines, shouldn't these corresponding angles be the same? So I can say 2x minus 15 will definitely equal x plus 55. And solve for x. Let's subtract x from both sides. Minus x, and get x minus 15 equals 55, because that was my way. And then add 15 to both sides, and x equals 70. But don't forget, we need to justify our reason. How did I know I could set that equation up? They gave me parallel lines, and that implied that my corresponding angles will be congruent.